Deleting is just slightly more complicated than inserting. So basically at the beginning we find where the element is. So let's say the element is in a leaf node V, and then we delete the element from the leaf node. If then V has at least a elements, then we're done. So the only time we have to do something is when V has a -1 elements in it. In this case, we do this operation. We fuse V with its sibling. In other words, we completely merge the two adjacent nodes together. And we also delete a reference element from the parent of V. Okay. So now we have the elements where the deletion is complete. Again, but the problem we could have is that what if the V, the new fused vertex, has more than B elements? Okay. If it has more than B elements, we split it, and we're basically, in that case, we're done. But otherwise, if it does not, then we have actually successfully managed to fix V, but at the cost of reducing the number of children of the parent of V by 1. Because when you merge two children of a node, that's equivalent to deleting an element from the parent. So that means that suddenly the parent could have one fewer node. In that case, we go to the parent and we repeat the same operation again. And as before with the insertion, once we reach a node root, we are done, because in that case, the only case or the only example we might do is that we might need to delete the root if necessary, because if a root ends up being with the degree 1, then we can just delete it and just create a new root. So again, deletion costs touches log base A of n nodes. There's also an example with deletion. So for example, in this case, the last element of this node is deleted. And now this leaf has one element, which is not enough, because we want the leaves to have between 2 and 4 elements in them. So then we have to do fuse operation. So the fuse operation is done. Okay. And now the parent has a problem. The leaf is fine because the leaf has 3 elements in it, but the parent of the leaf node has only degree 1. So therefore this node needs to be fused with that node. Okay. And now this node overflows because it has 5 children, so it's split again. And then you can see that we're done. Because if you do a fuse and a split, then the degree of the parent doesn't change. So therefore at that point the operation stops.